14a. A pattern is made from two similar trapeziums. Show that the shaded area is 294 centimeters squared. If they're similar, that means there's a scale factor between them, a number that if we multiply one length, we'll get the corresponding length on the other shape. So this length corresponds to this length here. It's been rotated. So we need to divide 10 divided by 4, which is 2.5. That's our scale factor. So the large shape is 2.5 times bigger than the small shape. Next, we need to calculate some other. Next, we need to calculate the height of the small one. We have the height of the larger shape, but we don't have the height of the small shape yet. So in order to do that, we can do 25, the height of the large shape, divided by the scale factor, that's 2.5, equals 10 centimeters. So this length here is 10 centimeters. The other length we need is this one here to calculate the area of the small trapezium, and that's the corresponding length to that is this length here. So we need to take 18, divide it by 2.5 because it's 2.5 times larger, which is 7.2 centimeters. Next, we need to find the area of these two shapes. So let's find the area of the large trapezium. So if we call the large trapezium A and the small one B. So area of A, find the area of the trapezium, we need to average the two parallel sides. That's a half of 18 plus 10, and then multiply by the height. That's 25. Gives us an area of that shape of 350 centimeters squared. For the small shape, we'll do the same thing. So the average of the two parallel sides, that's 4 plus 7.2, multiplied by the height of 10, which gives us an area of the small shape of 56 centimeters. Finally, to find the area of the shaded area, we just need to take the small one away from the large shape since the small one is completely inside it. So 350 minus 56 equals 294 centimeters squared. 14b. The pattern has one line of symmetry. Work out the size of angle x. So here's angle x, and we know that these two lines are parallel since we have a trapezium. So if we are to extend this to here, that has to be angle x as well, since these are alternate angles. We have a right angle there. If we knew this side length here, we could use trigonometry to calculate the value of angle x. We know that it has one line of symmetry, which is likely down the middle here, we can see. So there's going to be a similar side on this side of the shape. Find out the side length, we can do 18 take away 10, which gives us the total of these two lengths. That's 8 centimeters in total, and since it's symmetrical, they both have to be the same size. So that's 8 divided by 2 will be 4 centimeters. Next, let's label our triangle for trigonometry. If this is the angle we want to calculate, we have the opposite side and we have the adjacent side. This is the hypotenuse here. That means we'll want to use the ratio for tan, which is opposite over adjacent. Now let's put some values in. So tan x equals 25 over 4. So that means to calculate x, we'll have to do inverse tan of 25 over 4, which gives us the value 81 degrees, the two significant figures.